Hello, in this video we're going to continue with P5 fractions, but before we do, please consider subscribing to the channel because you do not want to miss any videos that I'm going to upload in the future. And you can find the resources in the description, the link for the resources in the description below. So today we're going to look at the next part of fractions. We're going to look at this kind of questions. This is a common question that is, you can find them a lot in exam papers. So for this particular one, they will ask how many sixes are there in 2/3. So two things you need to take note of. Okay, the first one will be this particular word here, sixes. And the second one is the denominators. There's two ways that I would approach this question. Again, it's up to you to choose which one you feel is easier for you. So the first one would be just taking this fraction here, 2/3, and then multiplying it by this number here, 6, but you just change it to a whole number 6. So when you multiply, this is the normal multiplication, fraction multiplying by a whole number. First thing you would do is, if you remember from the previous session, the 6 is a whole number. You can give it a denominator of 1, and you can simplify the 3 and the 6. So to recap, as long as there's one numerator and one denominator, you can simplify the fraction. So we'll divide this by 3, you get 1, divide this by 3, you will get 2. So you get 2 times 2 and 1 times 1, that will give you 4 over 1, which simply is just 4. So this is the answer, 4. Another way would be to change the denominator. Change the denominator to 6. So what we'll do is we'll times 2 here and times 2 here. You'll get 4 over 6, and the answer is the numerator. So we have the same answer, two different methods that you can choose to solve this kind of question. Okay, we will look at the next one here. How many nines are there in 1 whole 4 over 9? So again, the two important things that you should take note of here, the first one is the nines, and the second one is the denominator 9. Now, for this case, it's different from the one above. The question before this, the denominator and this particular word here, they are different. So you need to change to the same denominator if you choose to do method 2. But if you choose to do method 1, so let's see how we're going to solve this using both methods, starting with method 1. So we'll have 1 whole 4 over 9, and we're going to use the multiplication method and multiply by 9. Where did we get the 9 from? From here, ninths. So this is mixed number multiplied by a whole number. Again, there's different methods to solve this multiplication. You can multiply the whole number and the whole number first, and then you multiply the fraction and the whole number. So if let's say you prefer that way, so you will take 1 multiply by 9 first. That will give you 9, and then you will take the fraction 4 over 9 multiply by 9, and we can simply simplify this fraction, and we'll get 4, and we're going to add the first answer to the second answer, which is 9 plus 4, and that will give us 13. So that's the answer, 13. Now, still using the first method, the other way would be to change this mixed number, okay, into an improper fraction. Alright, so for those who need a recap on how to change a mixed number to improper fraction, you basically multiply these two numbers, the denominator and the whole number, and you add the answer to the numerator. So 9 times 1 is 9, plus 4 is 13. So you have 13 over 9. The denominator remains the same. Now you can do the multiplication. Okay, so the multiplication is quite straightforward. You have 13 over 9 multiply with 9, and you can simplify this. So you cancel both divided by 9, and you will have 13 as your answer. Okay, so now the second method is the same as this second way of multiplying, because basically all you need to do is change this mixed number into an improper fraction. Okay, so the second method here, you cannot end up with a mixed number. You must end up with either an improper fraction or a proper fraction. And the second thing you must take note of is that the denominator must be the same as this word here. Okay, so we know this word is 9 and the denominator is 9. So there's nothing we need to do to the denominator. So we just need to convert this mixed number to improper fraction. So again, the method is multiply these two and then add to the numerator. So 9 times 1 is 9, plus 4 is 13. 13 over 9. So that's your answer, 13. Alright, so there's two methods. One is by multiplying. One is just by changing the fraction if it's a mixed number to improper fraction. If it's already a proper fraction, you just leave it and then you just change the denominator to the required denominator. For the first case, we change it to 6, and the second case, we change it to 9. So it's again up to you which method you prefer. Alright, next question, still the same. And you can see here quarters, and we have this denominator 4. So we have no issue here again. So if we do the first method, we do the multiplication, we will have 3 1/4 times 4. So what we're going to do first, we're going to multiply the whole number with the whole number. So 3 and 4 makes 12. 3 times 4, that will give us 12. And then we're going to do the next part, which is fraction times the whole number. We can simplify these two and we just get 1. So we'll add these two answers and we get 13 for this. So there are 13 quarters in 3 1/4. Okay, and for the second method, 3 1/4, you change it from a mixed number to an improper fraction. So multiply the denominator and whole number, and then we add to the numerator. 4 times 3 is 12, plus 1 is 13. 13 over 4, and do not forget to check. Make sure the denominator is the correct denominator. So this is the answer. The numerator is the answer, 13. Next question is something that we have done before. Multiplication of fraction with a whole number. So we're going to go through this quickly. The method again is to simplify. You can put a 1 here. And we're going to simplify any numerator with any denominator. Again, it doesn't have to be from the same fraction. So we'll simplify the 5 and the 80. We'll divide both by 5. And we get 1 for this. And for this, we will get 80 divided by 5 is 16. 16. So now we have 4 times 16 and 1 times 1. So 4 times 16 is 40, 24, 64 over 1. And that will just give us 64. So that's the answer, 64. Alright, and the next one is just testing your knowledge, your concept. See if you know what this word means. And this is actually a very important concept that you should know. Basically, of simply means multiply, or rather fraction of something means the fraction multiplied by that something. So this is 8 over 9 of 7. It will mean 8 over 9 multiplied by 7. So we give the 7 a numerator, a denominator of 1. And for this case, we cannot simplify any further. And we look at the options given. This simply means numerator times numerator and denominator times denominator. And we can see option 1 is the correct answer. Okay, more practice on multiplication of fraction. As I've mentioned, we're going to go through this quite quickly because we have done this in the first part. So for those of you who have not seen the first part, please go through my channel. You'll find fraction, P5 fraction, part 1. Alright, so let's go through. 4 over 5 multiplied by 3 over 10. And we're going to simplify first. We can simplify the 4 and the 10, both divided by 2. You'll get 2 for the numerator here and 5 as the denominator. And then we can multiply the numerator with numerator and denominator with denominator. That will give us 6 over 25. And we can't simplify this any further. So that's how we're going to leave our answer as. So remember, do not leave your answer unless you okay, what I'm trying to say is please simplify all your answers and do not leave it in improper fraction. So if you have your answer after you do your working and the answer is an improper fraction, please change it to mixed number and do not forget to simplify. Okay, next question. Again, same thing, multiplication question, 7 over 9. So remember, product simply means multiplication. 7 over 9 multiplied by 3/4. And here they remind you to leave your answer in its simplest form. So we're going to simplify these two. Divide by 3, we get 7 over 12. And that's our answer. Okay, so I mentioned just now, if your answer is an improper fraction, do not leave it as improper fraction. So we're going to go through this question here and you will see an example. Again, product simply means multiply. That's all. Half multiplied by, or rather 1/2 multiplied by 19 over 4. For this case, we cannot simplify. So we'll just go straight to multiplying the numerator with the numerator and denominator with the denominator. So we'll get 19 over 8. As you can see, this is an improper fraction. So we will have to convert it to a mixed number. In case you forgot how to do it, this simply means 19 divided by 8. And if you need to do the working, it's 19 divided by 8. Okay, so we'll get 2. 8 times 2 is 16. 19 minus 16 is 3. To recap this, the quotient will be your whole number and you're left with two other digits, the 8 and the 3, and the larger digit will be the denominator, the smaller digit will be the numerator. So this is your answer, 2, 3 over 8. Quite straightforward question. Moving on, next question, number line question. What is the mixed number represented by A? For this question, actually it's quite straightforward also, because you have 4 parts from 2 to the middle line here, and another 4 parts to get to 3. So from 2 to 3, actually there are 8 total parts. Alright, so there are 8 total parts. So basically you are just dividing the number line. And this would be the 5th line. So we'll count it together. 1, 2, 3, 4, 5. So this is 5 out of 8 total parts. So your answer would be 2, 5 over 8. So A will be 2, 5 over 8. Now the next question here. This is something a lot of students tend to make mistake in. They are not very sure how to compare fractions. Now there's 2 ways which I will recommend to compare fractions. Number 1, by making the denominator the same, finding common denominators. And number 2, finding common numerators. Now, for this particular question, we can see that the numerators are already the same. So what you need to understand is, for fractions, the denominator simply just means the total parts, the total number of parts. It doesn't mean that, oh, if the denominator is greater, that means there's more parts, that means the fraction is greater. No, it simply just means that you have the same things. Okay, for example, let's try to draw to visualize what it means here. So we have 2 fractions here. So I'm going to cut the first one into 2, and I'm going to shade one part here. So this is 1/2. And the second one, I'm going to cut into 4. So, okay, I'm going to shade one part to 1/4. As you can see, even though 1/4 has more parts, but each part is smaller. So the greater the number of parts you have, it simply means that you have to make more cuts. And the more cuts you make simply just means that the size of the fraction, or the size of each part rather, will become smaller. Let me show you another example. Let's say now we cut into 8 parts. And you can see one part is much smaller than 1/4. So that's how you can visualize the denominator when you compare the fractions. Alright? And for this case, since the numerator is the same, we can straight away compare the denominators. And you can see we want the biggest fraction here. So by cutting less, we will have the greater, or rather the greatest size. So 3/5, we only cut it into 5 pieces. So this would mean that it will have the biggest piece compared to the rest of the fraction. So again, this is one way to compare, by changing or by making the numerator the same. Now the other way is to make the denominator the same. Okay, so the first one again here, or rather this, in this example, we make the denominator the same. Okay, we're going to show you the second example by making the the denominator the same. So how would the fraction look like if we make the denominators the same? If we make the denominators the same, we're going to use this same fraction here, these same fractions here. So we have 1/2 and 1/4, and you can see here, when the numerators are the same, you can see clearly here, again a recap, that the more you cut, the smaller the size will be. Now what happens if, let's say, we'll shade 3 parts here. From this drawing itself, you can see clearly that 3/4 is greater than half. Now, here you see that the numerators are not the same and the denominators are not equal either. So what we can do is we can make the denominators the same. So when we want to change half, okay, the denominator, which is 2 to 4, we must multiply by 2. When we multiply by 2, we get 2 quarters. And this is done by cutting each of these. Now, when we do this, the denominators, when the denominators are the same, that means each unit is the same size. And we can now focus on the numerator. So if we take only 2 parts of 4, comparing with taking 3 parts out of 4, we will see that taking 3 parts out of 4 is greater than taking 2 parts out of 4. Okay, so usually in this method here, it's easier for students to visualize because greater number means bigger size. But for the first method just now, where we made the numerator the same, or rather for this case, the numerator has already been made the same for us, students tend to make a mistake. They would think that, oh, bigger number means bigger fraction. But no, remember, the denominator simply means how many pieces you have. So the greater the number of pieces, the more the cut, the smaller each piece would be. So if you take 3 out of 11, it is 3 small pieces compared to when you take 3 out of 5 pieces. The 3 pieces here would be greater than the 3 pieces here. Another question that students tend to make mistakes in is when they are supposed to find out which fraction is closest to a certain whole number. For this case, closest to 1. So what can you do to ensure that you don't make the same mistakes as or make the common mistakes as how or what the other students make? For this question, I would recommend to change the denominator to make the denominators the same. As you can see from the previous example, when the denominators are the same, that means the size of each unit is the same. And it's easier for us to compare. In this case, we can't compare, or rather we can't change all to the same denominator easily. So what we can do is we can compare certain groups of fractions first. We're going to compare these 3 first. Why did we choose these 3? Because all of them can be changed to a denominator of 12. So for the first one, we will take 3 times 3 and 4 times 3, which will give us 9 over 12. And the second one will be times 4 times 4. That will give us 16 over 12. And the third one, multiply by 2, that will give us 10 over 12. Now we can compare easily. The first one, in order to go to one whole, you need to add 3. Okay, it doesn't matter actually whether you add or you subtract. Okay, because you just need to know which one will get to 1 in the shortest possible way. Okay, so here for the first one, we need to add 3. For the second one, we need to subtract 4. Okay, so this is closer to 1 compared to this. And for the third fraction, we need to add 2. So among these 3, the third fraction is closest to 1 because you just need to add 2 more to the numerator to get 1 whole. Now we can compare 5, 6 and 6, 5. So let's change to a different color first. Let's change to green. We're going to compare these two now. And we're going to change the denominator to 30. So we will multiply this by 5. and the denominator multiplied by 5, we will get 25 over 30. And to go to one whole, you need to add 5 for this fraction. And the second one, 6 over 5, we will multiply by 6. We will get 36 over 30. And to go to one whole, you need to minus 6. So this is the closest to one whole. So the answer for this question is number 3. So again, this question is one that a lot of students tend to make mistakes in. My advice is to change the denominators to something common, to a common number, and then you compare by figuring out whether you need to add or subtract to get to one whole. Alright, so to recap, when we compare the first three, again, why we compare the first three? Because all of them can have a denominator of 12. We can convert the denominators to 12, but for option 4, we can't. So we're just going to compare these three first. And option 3, for option 3, we just need to add 2 more to the numerator to get to 12. So it's the closest to 1. Then we can compare option 3 and option 4, because option 1 and option 2 is definitely not the correct answer. So when we compare option 4, we change the denominator to 30. And when we compare, option 3 just needs 5 more to get to one whole. And option 4, we need to take away 6 to get to one whole. Alright, next question. Next question is something that you must try to understand the concept here. Concept of multiplication. So when we look at this part here, or rather we look at this part here. Why are we looking at this part, not this part here? Because there's more than one multiplication that we have to do. Okay, there's more than one operations that we need to calculate here, and we have the empty or the blank space here. So when we look at this, what does this mean? This means that there are 39 groups of 1 over 6 or 1/6. Alright, in other words, there's 39 of these 1/6. Now, a lot of students will make the mistake of just multiplying this and choosing that as the answer. What does this equal sign mean? This equal sign means, okay, for the equal sign, you will have the right side and the left hand side. So this is the left hand side, which is the left hand side, which is the left of the equal sign. Okay, and we have the other side, which is the right hand side, because it's on the right side of the equal sign. They must be equal. Alright, so to explain it a bit more, for example, okay, I'll show you the mistakes that a lot of students make first. They will make this mistake: 3 times 2 equals to blank plus 5. Most of them would just simply say, oh, the answer will be 6. Okay, so this is wrong. This does not mean 3 times 2 equal what, and then you plus 5. This simply means this side here, which is the left hand side, must equal to the right hand side. So you solve the left hand side first. 3 times 2 is 6, and this side must be 6. So what plus 5 equals 6? 1 plus 5 equals 6. So the answer here would be 1. Okay, so that's how you actually solve this kind of question. So now back to the original question. Let's erase this first so we have some space. Now, so 39 groups of 1 over 6 simply just means there's 39 of 1/6. Now we'll count on this side. We already have 8 here. So again, multiplication just simply means 8 groups of 1/6 here. So that means there's 8 of 1/6 here. And we already have 1 more here. So all together, we have 9 here. So we want to have 39. that simply just means we need 30 more. So this is the answer. So 30 times 1 over 6 is the answer for this question. Okay, again to recap. First of all, if you have an equal sign, the right hand side and the left hand side must be equal. So we'll solve the right hand side first. But for this kind of question, you don't even need to solve. Okay, some students, they will solve. And then they will try to solve this side also, the left hand side, which will be tedious. So for this kind of question, the easier way is to understand what multiplication means. Multiplication just means how many groups of something that you have. So for this case, you have 39 groups of 1/6, which means there's 39 of 1/6. Now we go to the left hand side, we must have 39 groups of 1/6 first also. So here we already have 8 and we have 1 here. So 8 plus 1, 6. Okay. 8, 1, 6 plus 1, 1, 6 will give you 9, 1, 6. So we need 30 more. Alright. So again, 8, 1, 6 here. 8 groups of 1, 6. And there's only one group of 1, 6 here. So 8 plus 1, we get 9. So we have, or rather we need 30 more. That's all. Okay. Now, the last page here. Okay, we have a few more questions here. For this question, you simply need to understand again the concept of denominator. Denominator simply means total. Okay, let's read the question first. The figure below is made up of triangles of the same size. Okay, that's very important. There are questions where they will give you triangles that are not the same size where you need to cut them. Okay, for example, I'll draw first. Later maybe I'll go through a bit more. Okay, they have questions which has different size of triangles. Okay, and maybe even different size, different shapes, maybe something like that. So you have triangles here that are the same size. Okay, and then okay, so let's try and shade this first. Okay, so these triangles here that I'm shading, they are all the same size. Okay, and then you have these two shapes that are not the same size. So first thing is you must check to make sure that they are the same shapes and they are the same size. So if they are not, for this case, you have to cut it. Okay, so you have to cut it to make them the same shape and the same size. Now back to our questions. Remember, denominator is the total. So that's the concept that you must try to remember and try to understand that the denominator is the total. Now, if we look at our shape and our denominator here, they're not the same because our denominator is 8. But how many triangles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we need to change the fraction that we have. Change the denominator to 16. Okay, we multiply 2. That means we will have 10 over 16. And the numerator simply means how many shaded triangles we need. So we actually need 10, not 5. We need 10 out of 16 triangles to be shaded. And here we already have 1, 2, 3, 4, 5. So we need 5 more. Okay. So if let's say the question is like what we have here. Okay, let's say we erase this. Okay, I'll give it a simpler question. Let's say the question simply asks how many or what fraction of the triangles are shaded, or what fraction of the figure is shaded. You cannot just simply count how many total pieces there are. 1, 2, 3, 4, 5, 6, 7, and you count how many shaded. 1, 2, 3, 4, 5. So you say 5 over 7. That's wrong because they are not the same shape and not the same size. So you need to cut here, and you get the actual total number of pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's actually 9 pieces total, and that will be our denominator. And 1, 2, 3, 4, 5. 5 of them are shaded. So the answer is 5 over 9. Okay, so take note of this type of questions where they do not have the same shape and the same size. Okay, the next question is similar to the question before. How many white stars must be replaced? Okay, for this time, they ask you to replace instead of shade. Okay, must be replaced by the gray star so that 4/5 of the total of the 4/5 of the total number of stars are gray. Again, the same concept. Denominator is the total. Now we'll count the total number of stars. 1, 2, 3, 4, 5. There's 5 here, and we have how many rows? 1, 2, 3, 4. So we have 4 rows. So 5, 10, 15, 20. Okay, 5 times 4 equals to 20. Okay, now we're going to change this 4/5, okay, to have a denominator of 20. That means we must multiply by 4. We will have 16 over 20. Okay, so currently we have 1, 2, 3, 4, 5. 5 over 20. So how many white stars must be replaced? It just simply means how many more must be shaded. So we have 5 over 20 here. We need 16. So 16 minus 5 equals to 11. So we need 11 more stars to be shaded. So we'll have 16 over 20, which is equals to 4/5. Alright. Down to the last 2 questions for this session of P5 fractions. This is similar to the one we did just now, where we have an equal sign and we have 2 equations, right and left. So the right equation must be equal to the left equation. And we can see the left equation is complete. There's no missing numbers, so we can solve this equation first. So it's 3 over 8 multiplied by 24. Something that we have done before, nothing new. We'll simplify first. Divide by 8, 1. Divide by 8, 3. So we have 3 times 3 equals to 9 over 1, which simply just means 9. Now, this is order of operation. So we have a blank times 12 plus 3. Okay, blank times 12 plus 3. A lot of students will have issue here because they will say, I can't choose any number, because if I choose the smallest number 1, 1 times 12 is 12 plus 3 is already 15. Okay, so you must get a smaller number. And what's that smaller number? It must be 6 plus 3 equals 9. 6 plus 3 equals 9. So we need 6 on this side. And how do we get 6? We will get 6 if we divide 12 by 2. Okay, if we divide 12 by 2, we will get 6. So how do we change the multiplication sign into a divide sign? Okay, simply by changing the whole number into a fraction. So 12 divided by 2, we want to get 6, we simply halve it. Okay, so half times 12 plus 3 will give us 9. Because half times 12 will give us 6. 6 plus 3 will give us 9, which is what the left hand side equals to. Okay, so this is a question that's not very direct, not very simple for most students. Okay, but I include it here in case if it comes out, so you can try to solve it and try to understand. But what's important is the common mistakes that a lot of them make, which is they do not know that if there's an equal sign, it means that the left side and the right side, there's two equations here, they must be equal to each other. Okay, so again, what is the mistake that most of them would make? They would simply just take 3 over 8 times 24 and you get the answer and they say, okay, this is answer 9, like that. Okay, but that's not right. Okay, so you must try to remember what this means. And the last part here, subtraction of two mixed number. Alright, for subtraction and addition, the rules are the same. What you need to do is have or make a common denominator. Okay, subtract 1 over 5 from 3 over 8. So we will take 3 over 8 first. Okay, so we'll take 3 over 8 minus 1 over 5. Now, how do you minus mixed number and a mixed number? Alright, first thing to do is change both fractions to common denominator. You don't need to do anything to the whole number stays, and you multiply this by 5, multiply this by 5, okay, and this side you multiply by 8 and multiply by 8. Remember, do not swap the places, keep them where they are. Alright, so you have 15 over 40 minus 1, 8 over 40. And next step is very simple. Numerator minus numerator. 3 minus 1 is 2. And then fraction minus fraction. 15 minus 8 is 7. And denominator, you just copy. Okay, so that's the last question for this session. And the next session, I will go through some word problems, common word problems that involve fraction. Okay, and this word problem can come in paper 1 or in paper 2. So again, do not forget to subscribe, because when I upload new videos, then you'll be notified and you can follow the updates and make sure that you do not miss any videos that I uploaded. Alright, thank you very much. So that's all for this lesson. It's a bit long. Alright, I hope to see you in the next video. Thank you very much.